Your content page called Evidence for the Big Bang talks about the 3 pieces of evidence that support the Big Bang. The first one is redshifted galaxies. Now, before we get there, you have to understand the Doppler effect, and you've experienced this in your everyday life. The Doppler effect, as we see here, is an increase or decrease in the frequency of a wave as the source and the observer move toward or away from each other. So if something making noise is moving towards you or away from you, there's going to be a noticeable change in the pitch of the sound. Let's check out an example of this. Go with a car and its horn. As you heard the car coming towards you, the pitch sounded higher. Beep, beep, beep. And then as soon as it passed, beep. The Doppler effect explains why the pitch went from higher to lower. We'll look at that in a second. Let's just see another example first. Same thing, the horn on the train went from higher pitch beep, beep, to beep.
Again, you might realize that that's maybe not a bad place to be. Sure, be a phony working him. Right.
And as you just heard, that race cars too, when you hear cars go by really fast, what you're hearing is the engine is actually not changing its pitch. It's just the fact that the sound waves coming at you are of a different frequency when they go past you. Let's look at it in a couple different ways. Let's look first at it like this. So imagine that there is an ambulance beeping its horn, right? Beep. The sound waves that it's emitting, if it is not moving, and you are not moving, those sound waves are going to be consistently spaced out. They're going to have the same wavelength, same frequency, right? Beep, and that's all you hear, beep. The sound does not change. It's the same pitch. But now let's say that ambulance or that van is moving as it's emitting that sound. Notice that as it's releasing the first sound wave, the next one is going to be closer as it moves towards you than the previous one. So as it's emitting waves as it is moving, it is squishing them closer together if it's coming towards you. Now, if that ambulance is going away from you, you're behind it, it's getting further away. As it's emitting sound waves, the first sound wave emitted will come to you, but the second one is going to be a little bit further away than normal than it would have been if the van was staying still, and so you would hear it at a lower pitch. Now that happens. This is one way to visualize it, right? Like this. But it can give the wrong idea that sound waves are just pieces of sound, like beep, 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 beep. So in reality, what it looks like is more like this. As a car is stationary, if it's beeping its horn, or let's say that's just the engine sound, the sound waves will be emitted at the same wavelength, same frequency. But now let's say that that car is going to go towards you. It's going to squish the sound waves because as it is emitting them, the waves are being shortened because the speed of the car is putting them closer together as they come towards you. And then as it passes you, the sound waves then are going to be the opposite. They're going to be stretched out. So if you were this person, you would hear a change in pitch. You would hear high pitch, beep, beep, beep. You would hear the pitch change. That's called the Doppler effect. Now that doesn't only happen with sound, but it can happen with light. Check out the next video.